Scene. All right. We have chapter 2 is functions. Exercise 1 of 20. Important topic to have all that many exercises. Just out of curiosity, what are the other ones? Chapter 3 is objects and chapter 4 is challenges. Functions allow us to reuse code that is helpful in multiple scenarios. For example, let's pretend we need to calculate the area of a circle. We can use the formula area equals pi times r squared, or in code, let r equal 5, let area equal 3.14 times r. This works great. The problem arises when there are multiple places in our code that need to get the area of a circle. Then we end up writing things like let r equal 5, let area 1 equal 3.14 times r, let r2 equal 7, let area 2 equal 3.14 times r2, let r3 equal 11, let area 3 equal 3.14 times r3. We want to use the same code, why repeat the work? Let's declare a new function called area of circle. Note that the function keyword is written before the function name and tells the computer that we're declaring a new function. Function area of circle r, braces, return 3.14 times r. The area of circle function takes one input, also called a parameter or argument, and returns a single output. We give our function the radius of a circle and we get back the area. To use the function, we can pass in any number as the input and capture the output into a new variable. Let radius equal 5, let area equal area of circle as a function of radius. The radius variable is passed into area of circle as r. That's r up here. After area of circle is done running, the result is returned using the return keyword. That's return here. The value returned is captured using the assignment operator equal into the area variable. That's over here. Now the assignment says on line 6, add a second function call to area of circle that passes 242 in as the radius. So that's area of circle as a function of 242. Capture the result in a new variable called big area. So for that we need to let big area equal area of circle 242. Let's try that. Correct. Okay, good. Multiple parameters. Functions can have multiple parameters, also known as inputs. Function add numbers of a and b, return a plus b. So again, a and b is what goes into the function, and the return keyword tells us what comes out of the function. Assignment. Until now, we have been adding up the damage a player deals every time they attack. Let's write a function called calculate damage that takes 3 numbers as its parameters and returns the result of adding them all together. Looks like it's already been done for me. Let's run this. That's confusing. Well, let's read the function. It says function calculate damage as a function of x, y, and z, braces, return x plus y plus z. Might need to mention this to someone, that this one's a little confusing. Where to declare functions. You've probably noticed that a variable needs to be declared before it's used. For example, the following doesn't work. Console.log my name, let my name equal Lane Wagner. That doesn't work. We can convince ourselves of that here. If we run this. Reference error, cannot access my name before initialization. Yes, reset the code. It needs to be let my name equal Lane Wagner, console.log my name. Code executes in order, so a variable needs to be created before it can be used. Functions break this rule. Because functions don't execute until they are called, they can be defined before or after the function call. Let sum equal add34 console.log sum. Then the function is defined, function add a comma b, return a plus b. That's a little mind-bending for me. But I guess all of this code must get read into the computer and or read into, is it a interpreter for JavaScript? I think it's an interpreter. Gets read into the interpreter. So by the time this actually runs, add has already been defined. Assignment. Let's create a function that allows players to print their character's full name in case they forget it. Define a new function at the end of the code called print name first and last. It should concatenate its two inputs and use console.log to print the result. So we can see that the provided code is already saying console.log print name of Frodo and Baggins. So the syntax again is first we write function, then we write the name of the function, that's print name. We define the inputs, first name and last name, let's call them that. We add our braces. This actually says define a new code at the end called print name of first and last. So we'll actually call this first and last in the way that it says. And then it's going to return first, last, and I'm going to put a space in the middle, even though I'm not sure if that's what it wants. It is what I want. Let's run. What if I took out the space? It's also correct. What if I put in too many spaces? Huh. That's a little surprising. Okay. Scope. Scope refers to where a variable or function is available to be updated or read from. For example, when we create variables in a function by giving names to our parameters, for example, that data isn't available outside the function. For example, function subtract x, y, return x minus y, let result equals subtract 5, 3, console.log x, x is undefined, print nothing. Let's convince ourselves of that. Reference error, subtract, subtract. Well, that's interesting. That's better. Reference error, x is not defined. When the subtract function is called, we assign the variable x to 5, but x only exists within the subtract function. If we try to print x outside of that function, then we won't get a result. Assignment. Find the bug in the code and fix it. Obviously the bug is that we're trying to print x out here when we don't have access to it. The question is, what is the code supposed to do? I'm going to make an assumption that it's supposed to print the result. Reset code. Wait, did I reset it? Oh, okay, never mind. Huh. That's better. Oh, okay, so let's look at this. Function get area of square as a function of height and width. Return height times width. Then we define let my height equal 4324. Let my width equal 5432. Console.log get area of square, height, width. Oops. This height and width is the same as inside of the function get area of square, but but we need it to be my height and my width, which are the variables available in the global scope. And when we run that, that's going to work out all right. Just for interest though, what if we go back to the way it was, try to run, reference error, height is not defined. That's because height only exists inside of the function. It doesn't exist out here where the function is being called. That's an interesting example. Okay, on to the next. Global scope. So far we've been working in the global scope. That means that when we define a variable or a function, that name is accessible in every other place in our program, even within other functions. For example, let pi equal 3.14, function getArea of circle as a function of radius, braces, return pi times radius times radius. Because pi was declared in the parent global scope, it is usable within the getArea of circle function. Assignment. Let's change how we are calculating our player's stats. The only thing we should need to define globally is the character level, and then let our functions do the rest. Declare the variable player level in the global scope and set it to 4. Okay, just that simple, huh? And we need to let player level equal 4. Run the code, and let's see what's happening in this example code. Let player health equal 4, function calculate health of modifier, return player level times modifier, function calculate primary stats of armor bonus comma modifier, return armor bonus plus modifier plus player level. Okay, that makes sense. And this is just printing the stuff. So the thing to notice is that player level was defined out here in the global scope, and it's available to this function and to this function. Scope quiz. Can functions access variables declared outside in the global scope? Yes, they can. Scope quiz. Can code access the scope of a function, Can code outside the scope of a function access variables that are inside that function? No, it cannot. That's like, an example of that is function, I don't want to write it here. I'm going to back up a few. That would be like function add x comma y, return x plus y, and then we go along and try to say console.log x. That doesn't make any sense because x is not defined outside of the function. Answer is no. Okay, we can go forward. Functions practice degrees. Let's take a break from working on Fantasy Quest for a moment. Instead, we will use what we've learned to build a function we could use in the real world. Write a function called toCelsius that converts the temperature in Fahrenheit to Celsius. So, function toCelsius. Oops. We'll say f be the I'll type it out, Fahrenheit. And let's see, I know there's a 9/5 and there's a 32 in there somewhere. How does it work? I think it's return you take the Fahrenheit value, you subtract 32 from it, and then you multiply by 5 and divide by 9. Okay, that's good. I'm glad I remembered how to put that formula together. So to review, we have a function, the name of the function is toCelsius. The parameter is Fahrenheit, and when we execute the function, we return that number for Fahrenheit, like it was 100 here, minus 32 times 5 divided by 9. Oops, don't want to move those around. Okay, moving forward. Functions practice exists. Let's get back to working on Fantasy Quest. We need to make a way to easily check if an item exists within our inventory. Complete the string exists function that checks if a given string can be found within an array. For example, string exists Sally in Bob, Joe, Bill returns false. String exists Sally in Bob, Sally, Bill returns true. And I can see that we've got some template code prepared for us. So we're defining the function string exists. We have string to check. We have string array. Let's look at an example of the data. String array could be iron bar, leather scraps, short sword. And the string to check could be healing potion. In that case, it's going to be false. Let's say that for I equals 0, this is the pattern we've seen from before. I less than string array dot length I plus plus. So what's that going to do? It's going to start at 0. It's going to iterate until I is not less than string array dot length, and it's going to go I is greater by 1 every time. Next, the condition, we can compare if, oh, we already have if, if string to check triple equals string array at position I. Return true, else we return false. Let's run that code. Correct. Okay, so again, this was an if block. The condition lives inside of the parentheses, and the condition I wanted to check was whether string to check is equal to the current element from the string array. And how do I get that? I take the string away and I address at the I index. Boolean logic. Boolean logic refers to dealing with Boolean, true or false values. For example, dogs must have 4 legs and weigh less than 100 kilograms. Both conditions must be true. Cars are cool if they go faster than 200 miles per hour or if they are electric. One condition must be true. Syntax. The and operator takes a Boolean value on each side and returns true if both values are true. So function is dog with number of legs and weight, return paren number of legs equal 4 and weight less than 100. Let's go over how this function evaluates given the parameters 4 and 99. Return 4 equal 4, that's true. 99 less than 100, that's true. So it's like it does return true and true. Now this AND operator takes the true and gives us true. Let's see what would happen with 3 and 98 instead. The function will return 3 triple equal 4, AND operator, logical AND operator, 98 less than 100. So that comes to false, logical AND operator, true. And since it's not both conditions, it is returned false. It says the logical AND operator will only return true if both conditions are true. The bar operator, which is the logical OR, returns true if either of the conditions are true. Functions is car cool, speed is electric, returns speed greater than 200, or is electric. Let's use a non-electric car that can do 250. Return 250 greater than 200, logical or false. So we're returning true or false, and that evaluates to true. So the function gives true. Assignment. We need a way for our game to track if a character's attack hits or misses. Complete the doesAttackHit function. The function should return true if either of the following conditions are met, so I can already put in an OR operator for the middle. If either of the following conditions are met, that's a typo there. The attack roll is not a 1, and the attack roll is greater than or equal to the armor class. So we actually need a paren and an AND operator in here. So attack roll not equal 1. And attack roll greater than armor class. And I'm going to put an extra paren in here, even though I think it's not necessary. I think that the greater than operator takes higher precedence than the logical AND operator, and I think the same thing of the not equal operator, but I'm going to put in parentheses there to make that explicit as well. The other OR is attack roll equal 20. Let's review this. This is a typo there. Return, we have condition of attack roll not equals 1. That's attack roll is not a 1. And attack roll is greater than armor class. And attack roll equals 20. Now let's see about what these are going to come out to. The attack roll is 17 and the armor is 18. So that's going to come out to, I think, false. Because the attack, we don't have that attack roll is greater to armor class. And we also don't have attack roll is 20, so this will be false. For the next one, does attack hit with 20 and 25? Well, we have attack roll equals 20, so that's true. This one's interesting. Attack roll is greater than armor class, so we get true here. But attack roll is equal to 1, so this not equal to 1 condition is false. So this whole AND thing is false, and this is gonna come out as false. What about 16 and 13? 16 is greater than 1, and our attack roll is greater than armor class, so we have this side satisfied, so that should be true. Next we have 25 and 21. We're okay on the left, on the overall left side, because attack roll is greater than armor class and attack roll does not equal 1. So that should be true. So if I did this right, we have false, true, false, true, true. False, true, false, true, true. Right on. A little bit longer to go before a break. Boolean quiz. Refer to the following Boolean statement. Let is tall equal true. Let is fat equal true. Let is skinny equal false. Let is short equal false. Let result equal is tall and is fat, or is skinny and is short. And we have true and true here. Those together with the AND operator will come out to true. And the OR operator with the false over here, we'll end up with true for this, or false for this, so it's going to come out to true. Hours to seconds. Let's take a break from Fantasy Quiz again to write another real world function. Write a function that converts hours to seconds. So we now have hours. We have our function. Remember, we write function for to define a function. Function name, the function parameters. In this case, there's just 1, hours. And we can multiply times 60 times 60. That should give us the right return value. First element from array. Exercise 13. Let's do some more work on Fantasy Quest. Let's add another function to our inventory system. Write a function that returns the first value from an array. If the array is empty, then return the string error instead. So here's the error string. And if items.length greater than 0, that's our check, which will allow us to return items 0, index 0 for the item at the first position. Function get first item of items. Okay, that's correct. Time for 1 or 2 more exercises. Should serve drinks. Assignment. In Fantasy Quest, players can go to a town's local pub. Drinking virtual beers refills their stamina. Complete the function that determines if a bartender should serve drinks to a customer. The function should return true only if all of the following conditions are met. The time is between 5 and 12 inclusive. The bartender is not on break. The customer's age is 21 or older. Tip: if statements don't need a comparison. What do they mean by that? Where is big is a Boolean value, the following statements are identical. If is big, or if is big equal to true. Oh, I see the difference. You should actually prefer the first option, however, because it tends to be more readable. The equal true is strictly redundant. Makes sense. Function should serve customer with customer age, on break, and time. So we're checking customer age first. If customer age less than 21, return false. That takes care of the customer age. If on break, return false. And if time less than 5, or the other one is time greater than 21, return false. And if all those get through, return true. Notice how we don't have to write else return true, because the function is, once a return keyword gets hit, that's the end of the function execution. Correct, okay. And there it is, time for a stream break. So let's get our short timer. Go onto our BRB screen. Okay, how we doing? I think I'm going to finish out this section on functions in this Boot.dev course, and then I'm going to either call the stream for now or move on to coding game. We'll see which one comes through. Let's see, scene. Okay. Right. Return true. We got through this one, so let's go on to the next. Find max. Our players want to see their strongest attack from their last combat. Let's add another function to analyze data from our combat log. Complete the function that looks at each number in an array and returns the maximum value. So we have our function find max of nums, let max so far equals 0. I guess we're assuming that nums must be greater than 0. We have a -1 here, but that doesn't end up hurting the overall answer. For let I equals 0, I less than nums.length, I plus plus, let num equal nums I. If, so we need to fill in an if condition, and if that comes out to be true, then max so far equals num. I'm going to say that that condition is if num greater than max so far. And then after all of that, after the if for loop with the if condition, return max so far. That should do it. Okay. Reverse array. Some of our players would like to view their inventories in reverse order. Let's write a function that takes an array as input and returns a new array except that all its items are in reverse order. For example, 1, 2, 3 goes to 3, 2, 1, and A, B, C, D goes to D, C, B, A. I think the simplest way to do this would be, well, we already have function reverse array of items. We have new array is an empty array. And we have for let I equals item.length -1. So we have the last index. I greater than or equal to 0, I minus minus. So I is going to be, length and length -1, or excuse me, length -1, which is last index. So I is going to be last index, and then second to last index, and then all the way down to 0. So we can just say new array. We can use a function we learned a while earlier today, which is push. And we can push items at I. Because items at I, that'll be the element in the I position of items. Okay. So from short sword to healing potion and so on, it prints kite, shield, iron breastplate, healing potion, short sword. Yep, that looks right. Read the first several paragraphs of this article on pure functions, okay? How to make pure functions in Go. Pure functions are often hyped up in JavaScript world, particularly because of the abundance of stateful front-end applications. While pure functions have their downsides, i.e. inconvenience, potentially large argument lists, they should be used as much as reasonably possible. What's a pure function? According to Wikipedia, a pure function has the following properties. Its return value is always the same for the same arguments. Its evaluation has no side effects, no mutation of data outside of the function. Which means that as a developer, I know two important things. When I call a pure function, I will get the same result every time. After calling a pure function, the rest of my program will be in the same state it was before calling it. So that brings us to this question, what is a pure function? A function with no side effects. It returns the same values when given the same inputs. Are pure functions generally harder to test? I would say pure functions would generally be easier to test because their results can be more predictable and isolated. And that's what the correct answer is according to this course. Okay, 19... exists a pure function. Pure function considered. Refer to the following code. Let threshold equal 10. Function get area of circle. Get function convert hours to seconds. Function exists. Items or exists item and items. For let item in array of items. If item equals item in array, return true. So let's analyze this. Is there anything in here that depends on something other than the inputs? Well, no. It's we have a new variable, let item in array, but that only comes from the values in items. And we're checking if item equals item in array, return true. So it's going to give the same answer every time we call it, and it's not going to change any other existing data. Now let's say is tall a pure function? Well, actually it's not, because it depends on the value of threshold. And is tall of height could give different results depending on whether threshold, was 7 or 38. And this function is perfectly capable of running when there are different values of threshold in place. So is tall a pure function? The answer is no.